We said this one was undefined, not because there wasn't an answer, but because I can put in any number I want here, and we said since there isn't an answer, it's undefined. That's why this one is undefined. So, the question is how do you know that a division in clock arithmetic or modular arithmetic, how do you know when they're undefined and when they're not? Well, you could just try doing them, right? We could try doing this one. She did it if we try starting at the number 4 and jumping back, start at the number 4 and jumping back in groups of 8 until we get to 0. We can go one group of 8, two groups of 8, right? I'm back. But if I did another group of 8, right, I can actually get back in 2 or 5 jumps or 8 jumps. And if I try and find the 4 divided by 8 being equal to 4 times the inverse of 8, and we say 8 times something gives me 1, I can never get to 1 when I multiply by 8. If I start at 0, I'll be 8. And then I do 8 more. And I do 8 more. So I can get there, but I can get there in several answers that are less than 12. Does that make sense? Okay. Anybody have any insights on when this happens and when it doesn't? I will just say this. If you do very many of these division problems in clocks, you will soon discover that you can tell whether it's going to be undefined just by looking at the problem. You don't have to do the problem to find it's undefined. You can just look at the problem and say, this one will be undefined. Go ahead, give me a problem, and I'll tell you whether it's defined or undefined. Make one up, anybody.
4 divided by 12.
4 divided by 12 in clock. It's got to be something higher than 12. 13? That one's defined. It will have an answer.
Is it because there's an odd date, like the clock is odd and the other two are even? Because on the other two problems, they're all even. Like the clock and the two numbers of the clock are even.
You've got a nice conjecture out there. You can check it out. Caitlin?
I was thinking because like they're all multiples of a number. So 2, it's all. So 2, 12, and 8. 2, 4, 6, 8, 12. So if we did 3, they all have multiples of 3 at the end.
So if I did 3 divided by 6 in clock 9,
Yeah.
that one is undefined.
Isn't it like whenever, like, if the divisor can fit evenly into the clock, then like you're gonna have that same pattern going around. You know what I mean? Like how.
What do you mean the divisor fit?
Like how.
This won't go into the clock evenly.
No, I mean the first number.
Oh, the dividend.
Yeah.
We got all kinds of conjectures going on here. Anyway. Some of you are kind of barking up the right tree, even. I don't know how critical it is you need to know this for the test, so I don't know that I want to go there. Because we have some other places we need to go today.
You can't leave me.
And now that you brought up the question.
I can, and I will. You see, this might be something for your teaching tip.
Create situational interest.
Create situational interest. There are some of you that are just dying out there. Some of you could care less. And you'll sleep just fine tonight not knowing. That's okay. That's okay. But I've made a decision as a teacher that knowing this particular fact is not important for where we're going. And then by avoiding going there, if any of you decide to pursue this, you'll figure it out. I mean, it's figure-outable, if that's a verb. And when you do, it will be powerful for you. And anyway, don't do that to students when the topic is going to be on their standards-based tests. And every student should know it. But I'm okay with you going to that and never learning this if you don't care to. I mean, but I'm hoping that some of you will maybe.
Summer. Right. Real summer. Maybe I'll email him. Is it? Because no, it's wrong. Dang it.
It'll be on. I've got an extra, so you might as well. True story. He was a senior in high school, and I gave him a problem to solve. I ought to share the problem with you. It's really a great problem. He solved the problem. The problem involved a Fibonacci sequence. And the question he had was, okay, I was able to solve the problem by using an iterative method to get to the answer. But he says, I'd like to know, is there a formula that I could, like if I want the 12th Fibonacci number or the 25th Fibonacci number, I could put a 25 in there or a 12 in there, and it would kick out the number. And I knew there was. I didn't know what it was. Couldn't remember it. I'd seen it before and I'd worked with it, but I knew there was one. I said, I don't know, when we spent a couple hours after school one night just exploring. And then a couple of weeks later he came in again. Could I come in and we explored again for another hour and a half or so. And then the year ended. And he went down to BYU. And the end of the school year came and he calls me up, could I come and see you? And we chatted about how school went and so on. He says, I've got something I need to show you. And he pulled out, and he had, over the course of those 2 semesters, he had 3 pages completely full where he had built from the ground up the formula for the Fibonacci sequence. Had I answered his question or looked it up on the internet and said, here it is, he would have just quit. And as it was, he had so much fun doing it. This is part of your assignment. So work together on it, but here's the rule. Proportional reasoning. This is how most teachers would start proportional reasoning. Class, a proportion is 2 ratios set equal to each other. That's a definition of a proportion. And anytime you want to solve a proportion where one of the things is unknown, let's say you don't know what D is, A, B, and C are numbers, what do? You guys all know, right? Cross multiply. So we just go like this. We say AD equals BC, and since D is the unknown, I can multiply B and C, and then what? Divide by A, and And that's the extent of proportional reasoning. So, for this assignment, you cannot set up a proportion. You must use proportional thinking, but you can't set up a proportion. You have to do it without cross-multiplying. Because most of you don't know why you can cross-multiply. Why does cross-multiplying work? We'll talk about that on Friday. And we'll talk about this is something you want your students to know, but not to begin with. So what you're going to do is you're going to pretend you're a 6th grader again, or a 5th grader. You're going to do this problem here, these problems. After you're done, you're going to read the article that I've got posted there at the bottom of the page. It's on iLearn. You're going to see how 5th and 6th graders, I can't remember whether is it 5th or 6th graders, solve these problems, and you're going to go, hey, that's the way I was doing this. And you don't use cross multiplication. So just think it through, and how would you do this? And go.